Hello everybody. I just made a video. I have not uploaded it yet, but I made a video on web server. In this video I basically made a server in Rust, and everything is the same. It's like 50 minutes of me learning different stuff, uh, uh, and making a video out of it to make it a bit more interesting. So if you want to, uh, you know learn some Rust with me, then you can hop into the video. It's 55 minutes long. It's not for everybody, but this video is for everybody. So this is in Rust, in a single threaded Rust. So I did this. So I have not read this multi-threaded stuff yet. It's talking about thread pool and stuff. I don't understand this at all. So I don't understand thread pool. There are like 4 threads and stuff. I don't care. So in this place, what I basically did is what you so I'll show you what it was. Okay, so before that it was basically this was not there. So this is basically the single threaded application. So this is the single threaded application, and because this thing is Rust is like blazingly fast, unlike Python. Even if we did multi-threading, it just happened so instantly that it like couldn't be noticed by us. So what I did here is I made a standard thread sleep. So it sleeps for 250 milliseconds. This basically means for this function to complete, it takes 1 out of 4 seconds. Oh, so 1 out of 4, what does it mean? So 0.25 seconds. Basically, in 1 second, there will be 4 of these functions that can be run. So this is a single-threaded Rust, single-threaded application. So you can like increase the size a little bit. So this is our import. We're just making a TCP build, making a TCP listener. We're just listening in the stream and just sending the function like in a single thread, like a loser. Okay, and then here, and it's just a handler, connection handler. But what's important here is we're using this time. So we are basically making it look like as if it is a bit more expensive function now. So I have written 2 scripts right here. Basically this one is just a counter, so the count variable is currently set to 0, and the count variable is as it is like currently set to 0. We can now I don't know, just do count equals 0, and okay, now we can do it again. The count variable is currently set to 0, so we can use the while loop to like actually count how much seconds has passed. We can do it from here as well, right here, but we can look at the clock down in the bottom right corner, but we're not going to do this. And in here we're going to send parallelly all these requests to this specific place. Okay, this is what we're going to do. And now first of all, let's start the counter. It's 1 second. Boom. Okay, it happened too quick. Oh, we got an error, of course, because it's not running. The server is not running, so we just basically got error here. So unfortunate here. Now this is a single-threaded application currently. Now the single-threaded application, we can save it. Oh, did we save it? So we basically saved it, and we can cargo run it. So we're currently running a single-threaded application, and we're going to send 100 requests, not more than that. Okay, we're just going to send 100 requests, and as only 4 requests can be processed per second, it must take 25 seconds. This is our guess, and we run it. So it's doing its thing. It has to take 25 seconds. It's basic mathematics, so it's gone 32. We have done 97, 98, so we're almost 50 here. So I've done 12 seconds. You know, our calculation is working properly. So we're making sure that this process is quite expensive process. So as you know, not this one, this handle connection is quite expensive because we have to wait for certain seconds, and it took us around 25 seconds. We probably did this here to like basically do this because Rust is extremely fast. So once again, no, it's gonna be fast. Now unlike the other things, now what happens if we basically turn on the threading mode? So basically we're like making like so much threads right now, basically. So we're handling the vectors, and then so we're making currently threads. So what this as you can see, now we need to import thread as well. So uncomment this, and there's no error here. So we're basically using a handler, and we're spawning threads, and for what's called like for if it goes down here, so like this code probably below probably never will be executed because it'll always be here in for loop. It's like infinite loop, but infinite loop at this moment, but we're talking about this here. So if it happens, I'm just putting this here for safety, basically, for handling this. And this is a handler. It needs to wait 250 seconds basically. Now we can run the same function. It took us 25 seconds last time. We're gonna take a look at this as well. So we're not gonna run this while loop. We're gonna do 100. We're not gonna do 100. We're gonna do 100 for now. Let's make it a fair competition. So let's do it a fair competition. So starting the counter. So it's just 2 seconds off. No problem. Oh shit. So we unfortunate guys. This is a single threaded application. We didn't cargo run again. So we stop it now. It's gonna be over. So unfortunate we didn't recompile it. Now it is a multi-threaded application, of course. We have to recompile and cargo run again. Now it has been recompiled. It's debugged, so it's not fully optimized at all. But Rust is fast, so we can just so we have for loop here, a for loop here, and our while loop here. So we start counting. The same 100 requests done blazingly fast. It was done in 3 seconds. The other process, when we're not using multi-threading, it took us basically 25 seconds. And now Rust with multi-threading did it in 3 seconds. We're using our processor fully. And now I'm going to show you something. So which basically means that it should be done in 30 seconds, right? And if you want to compute 1,000 of these requests, parallel requests, that Rust is getting, and we can start counting here. So if we start counting down, we're saying 1,000 requests here, guys, and look at the processor going full. Oh wow, and it basically this is going still. No, it broke, and it basically the command prompt. Oh my god, guys, it's amazing. So basically it just broke because 10,000 requests was just too fast, and it has not failed yet. Nothing is going wrong. It processed all those requests so freaking fast. We're gonna do that again, okay? So it's not 25 seconds. Look at the clock down here, okay? Look at the clock down here. We're gonna go full screen. We're gonna go full screen. Well, let's not look at the clock. Okay. It's multi-threading, 10,000 requests. Boom. It can't even handle. Okay. So basically the RAM couldn't handle the terminal broke on me. But the server did not, basically. So we're not gonna do 10,000 now. I guess it's a bit too much. Let's just do 500. 500. It can handle 500. Yeah, 105. So did it only go 100? So okay, I guess it only did 100 requests, but it's quick. Okay, it's extremely fast. And if we go up a bit more, you could probably see some requests being made. And this is the thing, guys. This thing is so fast with multi-threading. You get the point, okay? Let's not get an accurate data. We're not doing any scientific experiment right here. We're just intuitionally, I don't know, English is not my first language. So basically, we did that. So multi-threading makes it quick. It makes your code go blazingly fast, extremely quick, and the server can take it. That's all I have for today, and I guess this is all it. Have a great day, and this is it. This is multi-threading, and this is why many games nowadays are made in C++ and they use multi-threading capabilities. So yeah, if you're a game developer and if you want to do stuff in single thread, I'm sorry, your users will get around like 1 FPS. But if you use the more threads, you get more FPS basically, and even in servers. So yeah, in Rust it's talking about like let's not overload the processor here. Rust is talking about like I don't know, it's like talking about stupid thread pool and stuff, but I don't know what the hell it is. For my computer has 8 threads, freaking like I don't know, either 8 physical threads. I can do everything it wants. It's just a laptop. I wish I had a Threadripper though. It'd be great. So thank you very much. This has been Master Life with you, and we're gonna meet later on. And yeah, do not forget to use multi-threaded code. That's what you need to do. And it's probably the second most important thing, because the most important thing is incorporating some machine learning algorithms. I don't know anything about ML or deep learning or anything, but I think it is the future. I mean, everybody says so. Anyway, I'm more interested in like lower level programming languages that go blazingly fast more than something like Python. But I don't know. The community, the Rust community has managed to get into the Linux kernel. Okay, guys, we are inside. Our language now works for the Linux. Can be used to add features in the Linux kernel, in the mainline Linux kernel. We'll get that thing in TensorFlow as well. We'll get TensorFlow for Rust. It'll be rewritten. Okay, we'll get TensorFlow. Let's just wait. It's just a year. How much more should we wait? It's Rust, guys. We're gonna use macros. Thank you very much. It's been Masterlight. I don't know how to end videos, but have a great day.